All right, ladies and gentlemen, we're back for the Standard 9B lesson. Let's continue what we did in Standard 9A. So now we're going to talk about negative exponents. There's some weird rules here we got to pay really attention. If you take a base and raise it by a negative exponent, you're actually making the reciprocal. So a raised to the negative n is really 1 over a to the nth power. That negative allows us to flip it to the bottom, right? That's going to be true. It's going to flip to the other side no matter where it is. Here, a to the negative n and b to the negative n are going to turn into b to the n and a to the m, right? It flips, right? They move to the other side. Can you see that here? This one goes up. Ooh, excuse me. This one goes up there. That one comes down here, all right? So anything in negative power flips it. So let's do some practice on this. So we have x to the negative 1. We're going to flip it to the bottom. So we're going to make it 1 over x to the first, or 1 over x, okay? 6 to the negative 3. We're going to flip that and make it 1 over 6 to the 3. And then we're going to calculate it real fast. 216. Right, next one. 8 to the negative 1. 1 over 8. It's done. If you think about the middle section yesterday where we did stuff, we have 3, which does not have an exponent, or we could say it has a raised exponent of 1. That stays on top. It is not affected by the name. The x to the fourth moves to the bottom. So 3 times x to the negative fourth becomes 3 over x to the fourth. Here we have, just like our second example, x to the negative fifth over y to the negative second, y to the positive second over x to the positive fifth. That's going to be it. Here we have 2 to the fourth over a to the negative sixth. That negative 6 moves up to the top. 2 to the fourth times a to the sixth, or 16 a to the sixth. 16 a to the sixth. Right, I expanded that 2 to the fourth. It stays there because it was not negative. Quotient rules. This is going to also apply with our parentheses. So we have a to the m over a to the n. We can subtract to make a new number. Before we clear the other boxes, let's look at one of those. So a to the eighth over a to the third. I'm going to do I'm going to do a to the 8 minus 3, and I'm going to end up with a to the 5th as my answer. Here I have r to the 5th minus 8. That's going to give me r to the negative 3, which means I'm going to turn that into 1 over r to the third to follow our rules from the previous screen. 1 over r to the third. Next set of rules is if I have a over b raised to the m power, that's really a raised to the m and b raised to the m. We're going to distribute that just like we did when they were being multiplied. So for the example 3, I have 2 over 3 raised to the third power. So I'm going to have 2 to the third over 3 to the third. That's going to be 8 over 3 to the third is 27. Right? You'd probably want to simplify that if you could, but we can't. Here's another one. Now we have negatives. Now I have 1 over 5, all raised to the negative 2. I'm going to have that negative, let's flip our position first. So we're going to change it to 5 over 1, all raised to this second, and I'm going to distribute 5 squared over 1 squared. It's going to give me 25. It could be 25 over 1, but we'll simplify it to 25, okay? Oh, I forgot to click off the box. Here's the box for that one. We're going to, when it's a over b raised to the negative m, we're going to flip our order and then raise it to the positive version of that. We just did that on 4. We're going to do that again on 5. Let's switch this one to green so we can see it. Now I have x over 4, all raised to the negative 3. I'm going to flip it. 4 over x, all raised to positive 3. Then I'm going to distribute it just like we did for the middle rule. So 4 to the third over x to the third, or 64 over x to the third. All right, more sets of rules. Hey, if we're simplifying polynomials, you need to know this, right? Steps to simplifying polynomials. Apply the power rule to get rid of parentheses. Flip any negative exponents. Simplify any constants. Use the product and quotient rules to combine like bases. Flip any remaining negative exponents. Criteria for a completely simplified answer. No negative exponents, no parentheses, bases are all different, evaluate all numerical bases. So we need to apply all these rules together for the next set, all right? Let's take a look. Here's what we have. Question 1. I have 2 to the 8th over 2 to the negative 4th. I'm going to do, let's flip it up, so I'm going to make it 2 to the 8th times 2 to the 4th. Now we're multiplying these two, so I'm going to make it 2 to the 8 plus 4 is 12. And that's going to make 4,096. All right. Now we have t to the negative 4 over t to the negative 6. We're going to take those and flip them because they're both negative. So I'm going to have t to the 6th over t to the 4th. When we divide, we subtract. So I'm going to do t to the 6th minus 4. That's going to make t squared as my final answer. Question 3. Now I have x over 2 all raised to negative 3. That negative says I'm going to flip inside the parentheses first. So now I'm going to have 2 over x all raised to the third power, which is 2 to the third over x to the third, which is 8 over x to the third. That's all the criteria. No parentheses, no separate bases. The numeral base has been expanded. All right, now I have 3x squared all multiplied by negative 3. So the whole thing's raised to negative 3. So I'm going to start by handing that out. 3. No, I'm not. I apologize. I'm going to start by moving it to the base. So I'm going to move it down. I'm going to get 1 over 3 times x squared to the third. That's going to be 1 over 3 to the third times x. We're going to multiply it to the 6th. 3 to the third. So now I have 1 over 27 times x to the 6th. Now look, I have 3 times y to the third, all times 5 times y to the negative 4th. That negative 4th only applies to 5y, so I'm going to immediately get 3y to the third over 5y all to the 4th. Now I'm going to distribute that, so I have 3y to the third all over 5 to the 4th times y to the 4th. That's going to get 3y to the third over 625 y to the 4th. 3 and 625 don't reduce, but I can subtract here to get the y's. So I'm going to have 3 y to the negative 1 over 625, and then I'm going to move that negative back to the bottom. So I'm going to have 3 over 625 times y. All right. That was a big one. Lots of steps. Break it down. Don't try and do it all in one. You'll get too hard to keep track of. Last one, I have x to the 5th. I have a negative, Let's move them. So I'm going to make it x to the 5th times x to the 2nd over x to the 3rd. We're going to combine our bases. So x to the 7th over x to the 3rd. Then I'm going to subtract 7 minus 3. I'm going to end up with x to the 4th. All right. That's it. See what you can apply. Bring questions to